Welcome to the TD Happy Math Hour. These are your weekly interactive math reviews for Math 1332 and Math 2412, presented by Yvette Chuca, Ruben Carrizales, and Albert Isasi. This session will be recorded so that you may come back to it later. Also, it is recorded so others who may have missed out on today's events will be able to come back and watch it. So thank you very much. So now at this time, please mute your mics for best sound experience. Otherwise, the feedback could interfere with information we'll be sharing today. Without further ado, here is Ms. Yvette Chuca.
Hello, everyone. Happy Friday. So they'll be putting a link for 2412 if you have to go to 2412. Otherwise, we're going to get started today with logic, which is chapter 3 for your 1332 class. For the logic, we're going to be covering logic statements and truth tables. And so we'll get started here. So logic can be used in everyday life, right? For example, lawyers use it to construct valid arguments, analyze legal contracts, and to be able to communicate more effectively. Computer programmers design computer software, and electric engineers use logic to design circuits for smartphones and other technology. So it's not just for math or philosophy, but it could also be in our everyday life, we use it. For example, if you spend $50 on groceries today, then I'll have 100 left for the week. Or when you're trying to make decisions like, should I take I-10 today or should I take 375? And what happens if there is an accident? And so logic is used basically throughout our everyday life. So in math, we're going to go ahead and break it up into symbolic logic to help us communicate mathematically. And so we'll just get started with something basic like what is a statement, and then we'll go from there. So we're going to be looking at different types of sentences, and then we're going to talk about which ones are the ones that we're interested for logic. So here's just a couple of sentences. Is the test today? This is a question. Go get the newspaper. We call that a command. This is a nice car is more of an opinion type of statement. And then Denver is the capital of Colorado. This is a statement, but this statement can be clearly stated as a true fact or a false statement. So the ones that we're interested in is going to be a statement. So this is a definition for a statement for this chapter. Is a declarative statement that can either be true or false, but it cannot be both at the same time. Okay, so when you're looking at a sentence and you're trying to decide if this is a statement, you want to ask yourself, can this statement, can I say that it's either true or false, but not both? Okay, so let's do a couple of examples. So here, as I mentioned earlier, Denver is the capital of Colorado. I can look it up and I can see whether this is a true statement or whether it's a false statement. Since I can identify that it's a true statement, then for our math purposes for this chapter, we're going to say that it's a statement. Okay. This is a nice car. That could be true, but it could also be false depending on who you're talking to. So that is not a statement. Okay. So let's look at some problems here that you might see in your textbook, for example. So here we have the question is to identify whether the statement or the sentence is a statement. And so we have a few here. So the first one, Florida is a state in the United States. So you want to ask yourself, is this true? Can I say that it's true or can I say that it's false? And the answer here, we know that Florida is a state in the United States. So this is a true statement. So I can say that this is a statement. Okay, let's go to letter B. How are you? Again, ask yourself, can I say this is a true statement or a false statement? So here, this this sentence is not a statement because it is not a declarative sentence. It's actually a question, and I cannot assign it a true or false statement here. So this is going to be not a statement. Open the door, that's a command, right? So I cannot say that this is true or false. So this is going to be not a statement. In the year 2024, the President of the United States will be a woman. Okay. So this statement, we can look it up, and we know that this was a false statement. So this is a false statement. I can say it's false. So this is going to be a statement. But what if it said in the year 2029, the president would be a woman? Well, we don't know that whether the president would be a woman or not, but we can say that the answer to that will be either true or it will be either false. So that would still be a statement. 7,055 is a large number. To some of us, that is large, right? But for other people, this might not be a large number. So I cannot say that this is true, and I cannot say that it's false, because it's not a clear statement, right? So it's not clear whether it's a large number or not. Okay, let me go back one. Okay, so it's more of an opinion, so it cannot be proven to be true or false. So this would be not a statement. For the next one, x is greater than 3. Well, what happens here if x is -1? Okay, so if x is -1, is -1 greater than 3? That's a false statement, right? But what if x is 4? 4 is greater than 3? That's a true statement. So I can either say that it's true or I can say that it's false based on the value of x, but at no time will it be both. Okay, so this is still going to be a statement because it will never be both at the same time. 9 to the 9th power plus 2 is a prime number. Okay, so maybe we're not sure what a prime number is. Maybe you don't remember what a prime number is, or maybe you don't know what this number is if you do 9 to the 9th power, and that's okay. Here, the important thing that you want to ask yourself is whether you can say that this is true or false. So 9 squared, or 9 to the 9th power plus 2, we know that this number is going to be greater than 1, and every number after 1 is either prime or it's composite. And so no matter what the value is for this number, it's either going to be true, that it's prime, or it's going to be false. Okay, so even though I don't know the value, I can say that it's either true or it's going to be false. So for this one, it's going to be a statement. For h, we have x plus 1 is equal to 5. So for x here, depending on the value of x, I can say that it's a true statement or a false statement. For example, if x is 4, 4 plus 1 is equal to 5, that is true. But if x is 3, 3 plus 1 does not equal 5. That is false. But at any time, it cannot be both true and false. And so for this, it's going to be a statement because it's either true or it's false depending on the value of x. Okay. So these are the type of sentences or statements that we're going to be working with. And so for this slide, we just wanted to make sure that we can identify if something's a statement or if something is not a statement. Okay. What we're going to be doing is we're going to be taking these simple statements and we're going to connect them with something that we call connectives. And those connectives can be these words: and, or, if, then, and if and only if. These are connectors or connectives, and we're going to use these to connect two simple statements. So for example, I will attend the meeting, or I will go to Friday Happy Math Hour. So here, the first statement in red, that is a simple statement because I can say it's true or it's false. Or is my connective. I will go to Friday Happy Math Hour. So either you're going to go or you're not going to go. So that's true or false. And together, the whole sentence, you have two simple statements with a connective. Then we call that a compound statement. So together, we create a compound statement. And so the definition of a compound statement is a statement that conveys two or more ideas, which are simple statements. Okay. So if you attended Friday Happy Math Hour a few weeks ago, I mentioned that sometimes in mathematics, we don't want to write a lot, so we like using symbols. And so this chapter is one of those chapters where we're going to be using a lot of symbols. And so this is a table that you want to write, have it next to you, try to memorize it, refer back to it as much as you can. By the end of the chapter, you'll be able to recognize these symbols. But the symbols, this upwards arrow and the one pointing down, then you have the tilde here, the right arrow, and then the double arrow. So those are used to represent our connectives. Okay, so our connectives, remember, were the words and. So if you have the word and, you're going to use the symbol with the arrow pointing up. If you have the connective or, you're going to use the symbol with the arrow pointing down. If you have a negation, which we'll talk about in a little bit, you're going to use the tilde here for P. Any if-then statements will use the arrow. So we call that the conditional. And the if and only if are the biconditional. And so so these are your symbols that we'll be using, and we'll refer to them as we go through the session. Okay, so for these statements, we want to know whether they're true or false. And so the truth value of a simple statement is either true or it's false. As we discussed earlier, the truth value of a compound statement depends on the truth values of each of the simple statements and its connectives. Okay, and we'll see examples of that in a little bit. And then we can use a truth table to put it all together so that we can see what the truth values are going to be. So the negation of a statement, okay? So the negation, here's an example. So if your statement is, today is Friday, the negation of that is going to be the opposite. Today is not Friday. So today is Friday is a true statement. The negation is going to be the false statement. So today is Friday. The negation of that is today is not Friday. Now, if you start with the statement that is false, then the negation would be a statement that is true. Okay, and the symbol we use for negation is this little tilde sign. And so in chapter 2, you used it for equivalent, but now we're going to use it for negation. So you want to make sure that when you see this, it's not the one for the sets. It's going to be a new term for negation, or a new symbol for negation. Okay, so again, you want to remember, if you start with a true statement, then the negation would be false. If you start with a false statement, then the negation would be true. So we're going to practice just writing the negation of a statement. So here's 4 examples, and the question is, write the negation of each statement. So we have Ellie Goulding is an opera singer, and then we have the dog does not need to be fed, the fire engine is not red, and the Queen Mary 2 is the world's largest cruise ship. So we'll start with the first one. And I changed it. I guess I forgot to change it over here. But I went ahead and I put Jordan is an opera singer. So the negation of this is going to be Jordan is not an opera singer. Okay. So really what we're adding is that word not, right? So Jordan is an opera singer. Jordan is not an opera singer. So let's say that this was a false statement, then this solution here would be a true statement, and vice versa. So the dog does not need to be fed. Okay. So here the dog does not need to be fed. So what is the opposite of that? The dog needs to be fed. Okay, so that would be the negation. So the dog does not need to be fed. The opposite of that is the dog needs to be fed. The fire engine is not red. So the opposite of that is the fire engine is red. And then the last one, the Queen Mary 2 is the world's largest cruise ship. So right now, I don't know what the Queen Mary 2, if that is or if it's not the world's largest cruise ship. I know that it's either true or it's either false, but I can write the negation by saying that the Queen Mary 2 is not the world's largest cruise ship. Okay. So these are the negations. If you have any questions at any time, feel free to ask. Let's continue. So now what we want to do is we want to practice writing these in symbolic form. Okay, so what you're going to see in your homeworks or in your textbook is they're going to give you some simple statements, and we use these letters P, Q, R, and S. I forgot to mention that earlier when I had the symbols over here. Let me see. Oh no, I guess not. I didn't put it here. But we usually use P, Q, R, and S to represent the simple statements. Okay, so here P is going to be today is Friday. Q is going to be it is raining. R is I am going to a movie. And then S, I am not going to the basketball game. So the question is write the following compound statements in symbolic form. Okay, so we want to write them in symbolic form. And so to do that, I'm gonna bring up the table on the right side. That way we can refer back to it. So the first one, today is Friday. I highlighted it in yellow. So if I come up here, P is today is Friday. So I write the letter P. Then my simple statement is connected with the connective and. So if I go to my table, the connective and uses a symbol with the arrow pointing up. So I write my arrow pointing up. And then my other simple statement is it is raining. So if I come to my statements, Q is it is raining. So I write Q. So this statement, today is Friday and it is raining, can be written in symbolic form as P and then conjunction Q. Okay, so the conjunction just is used as a symbol and it's the word and. All right, so our next statement, it is not raining and I am going to a movie. So if I look at my P, Q, R, and S, I don't see it is not raining anywhere here, right? But if you notice, it is raining is here. That sounds like the negation. So what we can do first is write the negation. And the symbol for negation is this one here. So negation Q is it is not raining. So if you wanted to make it easier when you're doing these, you can write the negation for all of them because they might appear and you might need them. So today is Friday, the negation would be what? Today is not Friday. Today is not Friday. And so on. So you can do that for each one, and then you would have it ready in case it comes up in your problems. Okay, so let's go ahead and continue. So here it says it is not raining. So we just said that was negation Q. My connective is and, so I use the arrow pointing up. I am going to a movie. So let's check over here. I am going to a movie is R, so I write R. So in symbolic, this would be negation Q and R. So that would be my answer. Letter C, I'm going to the basketball game or I'm going to a movie. Okay, so you want to identify your simple statements. You want to identify your connective. In this case, or is my connective. And so for or, we have the disjunction, and the symbol for that is the arrow pointing down. And so if I highlight these, so here I highlighted my disjunction, my symbol, my connective. So I'm going to the basketball game. So if I look at my statements, yes, I am not going to the basketball game. So that means the negation for that is I am not going to the basketball game, or I am going to the basketball game. So let me fix that. Let me cross that out. Okay, so S is I am not going to the basketball game. So the negation of S is I am going to the basketball game. Okay, so if we read the sentence, I am going to the basketball game, we just said is negation S. So here's negation S. Or is my arrow pointing down, the disjunction. I am going to a movie. So I'm going to the movie is R. So in symbols, we get negation S, disjunction R. And then the last one, we have if it is raining, then I am not going to the basketball game. So if your sentence starts with if, then we're working with the if-then statement. So our connective would be if-then, with the symbol being the arrow pointing to the right. So here I highlighted the word if and then so that I can identify that I'm working with if-then statement. If it is raining, so it is raining is Q. So I write down Q. Then, so my arrow, I am not going to the basketball game. So S is I am not going to the basketball game. So my symbolic form would be Q. And then we have our conditional, the arrow, and then S. Okay, so this is how we go from the English sentence to symbolic. And I believe we're going to go the other way now. Okay, so here it says translate into English statements. So they give you the P, Q, R, and S. And so we have write each of the following symbolic statements in words. So we have Q, conjunction P, and then let's do that one first. So if it helps, again, at the beginning, you can have this next to you. So depending on your instructor, they might let you use a table like this. If they don't, then you will have to memorize that and is the arrow pointing up, and it's called the conjunction, and so on. So here, Q. So we would look for Q first. Q is the game will be shown on CBS. So we write the game will be shown on CBS. Then we have the arrow pointing up. So that's going to be the word and. So I write my word and. And then P is the game will be played in Atlanta. And the game will be played in Atlanta. Okay, so that is the translation to English. Now let's go to letter B. So this should be the negation of R. So I apologize for my symbol there, but it should be the same as this one, the tilde here. So negation of R, if R is the game will not be shown, then the negation of R is the game will be shown. So I write the game will be shown on ESPN. I have my connective, which is the conjunction. So that's the word and. S, the Mets are favored to win. So the Mets are favored to win. So now letter C, we have a new symbol. The double arrows here is going to be your biconditional. And so we have S, biconditional, negation P. So in your mind right now, you have P, what would be the negation P? So if P is the game will be played in Atlanta, then think about what would be my negation for that. Okay, so let's see if you got it correct. I'll click on the slide here in about 20 seconds if you want to try it. Okay, so the negation P, the game will be played in Atlanta, so the negation will be the game will not be played in Atlanta. So now we go to S. S is the Mets are favored to win. And then the double arrow is if and only if. So I substitute my double arrow for if and only if. Negation P, the game will not be played in Atlanta. Any questions on that one? Okay. So now it gets a little bit, now we have more statements and now we see parentheses in there. So parentheses will help us to figure out what is grouped together. Okay, so for example, the first one we have P, and then we have the conjunction, and then we have a parentheses, and then we have Q, disjunction, negation R. So the parentheses here is telling us that when we're doing our work here, we're gonna group Q and negative, not negative, the negation of R together. In the second one, P and Q are grouped together. And then the last one, P and the negation of Q are grouped together, and R, disjunction S, are grouped together. Now, if we have if we have a sentence, then how do we know what to group together? And so if a compound statement is written as an English sentence, then a comma is used to indicate which simple statements are grouped together. So statements that are on the same side of a comma are grouped together. So if we see this sentence here, we have P, comma, and Q are not R. That means that Q and not R would be grouped together, okay? And then on the second one, we have P and Q. So P and Q would be grouped together, and then the R would be by itself. If P and not Q, so there's my comma, that means that P and the negation of Q are together, and R and S are going to be grouped together. And so you'll see it here in the next slide. It's a little bit more clear. So let's say you have P is you get a promotion, Q is you complete the training, R you receive a bonus. So it says write this statement as an English sentence. So we know that P and Q are together because of the parentheses. So when you write it in an English sentence, you're going to put the comma so that these two are on the left side together. Okay, so you'll see it here. So it says P. So P is you get a promotion, right? Notice that I have an arrow pointing to the right. So that means that this is a conditional statement. So I'm going to use if. So if you get a promotion, and then you have your connective and, you complete the training, and then my parentheses. So now I know I need a comma. So there's my comma. Then R, you will receive a bonus. So in English, it would be read as if you get a promotion and complete the training, comma, then you will receive a bonus. Okay, so for letter B, we want to write it in symbols now. If you do not complete the training, then you will not get a promotion and you will not receive a bonus. So here, what we're grouping together is after the comma. So we're going to group together, you will not get a promotion and you will not receive a bonus. Okay, so let's see what that looks like. So if you do not complete the training, so let's go up here for Q. Q is you complete the training. So the negation of Q is you do not complete the training. So I'm going to use the symbol for the negation. So I have negation of Q. Then, so here's my arrow for the if then statement. And I already have my comma, so I'm going to use parentheses. You will not get a promotion. Well, P is you get a promotion, so the negation of that is not, so I'm going to use negation P. And so I use my conjunction, and then you will not receive a bonus, negation R. So this would be your answer. All right, so now we're going to get into how do we construct the truth table. So the truth table comes from this is like your general truth table. So if you have two statements, we're gonna go with P would be true, true, false, false. So these are just all the possibilities for P. So for that simple statement, these are all the possibilities if you have two statements. If you have three statements, then we go with true, 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 false, false, false. Then for Q, it alternates every two. So true, true, false, false, true, true, false, false. And then the last one alternates true, false, and so on. So we're going to focus on the one with two statements first, and then we'll continue with the three statements. So in these tables, here we have P is true, true, false, false. And then Q is true, false, true, false. On the right side of your two simple statements, this is where the work is going to be. So if you have negation P, then negation P we said is the opposite, right? So we were using the word not, so it's the opposite. So if P is true, then the negation of P is going to be false. Here P is true, so the negation of that would be false. And then P is false. So the negation would be the opposite, which is true. And then the last one is false, so then you would have a true. Okay. Now for the conjunction, we have the following. So we want to know what happens, how do we end up with these answers over here? Okay, so let me give you an example. Let's say that you have, I'm going to hire somebody for a job, and there's a newspaper posting, and it says that I'm hiring a person that has a bachelor's in math and 10 years of experience. Okay, so we want to know, does this person qualify for this job? Okay, so if the person has a bachelor's and 10 years of experience, I'm going to hire them because they have the requirements. Okay, so here, these are all the possibilities. So a person that has a bachelor's and the 10 years of experience, do they qualify for my job? Yes, so that's going to be true. Okay. Does a person that has a bachelor's but doesn't have the experience, do they qualify for my job? No, so that's false. If they don't have the bachelor's but they have the 10 years experience, do they qualify? No. If they don't have either or none of them, then they don't qualify either. So the only way that I can hire this person is when they're both true, when they both have the bachelor's and the experience. So for conjunction, whenever you see the symbol for and for the conjunction, your table is only going to be true when they're both true, when the two simple statements are true. Okay, now let's look at the disjunction. So let's say that I'm going to hire somebody, but now my little ad says, if you have a bachelor's degree or 10 years of experience, then you qualify. Okay, so if the person has a bachelor's and they have 10 years of experience, do they qualify for my job? Yes, because they have either or. If they have a bachelor's but no experience, do they still qualify? Yes, because the ad says or, right? If they don't have a bachelor's but they have a 10-year experience, they still qualify. And if they don't have either, then it's going to be false. So for your disjunction, it's going to be true as long as one or the other one is true. If they're both false, then it's false. And then for the conditional, for this one, I guess the sentence I could use would be something like this. Let me see. If you run 10 laps, then I will buy you a car. Okay, so let's see what happens here. So let's say that I'm talking to my nephew, and I say, if you run 10 laps, then you will get a car. So let's say that my nephew runs the 10 laps, then that's true. And I give him the car, then that's true. Did I break any promises or anything? No. So then this whole statement is true. I did what I said I would do. Here, let's see what happens with my nephew here. He ran the 10 laps. I'm sorry. Yeah, he ran the 10 laps, but then I didn't give him the car. Did I keep my word? No, so this is false. But let's say that my nephew did not run the 10 laps, but I still gave him the car. Nothing wrong with that, right? I still was nice enough. I gave him the car. Let's say he didn't run the laps. I didn't give him a car. I didn't break any promises, so that's still going to be true. So the conditional is only going to be false whenever you have where the first statement is true and then your Q is false. And then the last one, and we'll talk about conditional and biconditional in more detail later, probably like next week. But for the biconditional, here it's whenever the two statements are the same, that's when it's going to be true. So if they're both true, then it's true. If they're both false, then it's true. Otherwise, it's going to be false. But let's go ahead and do some examples here. I'm going to switch computers really quick. So give me a second. And I'm doing that so that I can use my pen. All right, so let me use my pen here. Let me refresh because I think it kicked me out. So it's refreshing. So here, one of the things that there's different ways to do a truth table. Your book, I think, will explain 2 ways, but I'm just gonna go ahead and explain the way that, in my opinion, I think it's easier, but I could be wrong, right? So I do encourage you to read both ways, but usually most of us stick with one way. So what you want to do first is decide which table you want to use. Okay, so since you have 2 statements, P and Q, then we're going to use P and Q. And so in that general statements is that we have true, true, false, and false. And for Q, it alternates. And these two columns are always going to be the same. Okay, these will always be the same for 2 statements. So true, true, false, false, true, false, true, false. If you have 3 statements, and I have an example here, we'll look at it in a few minutes, then your first 2 columns would change a little bit. So then I'm going to write negation P and Q. So the first thing you want to do is treat each statement on its own, for example, and then we'll figure out what the rest is together. So here I have negation P. So what you want to do is, well, if P is true, right, if it's true, the negation of P is going to be false. Okay. And then for the second one, if I have true, my negation is false. And then the third one, if it's false, it's going to be true. And then false would be true. So false, false, true, true. So I'm going to label this as number 1. Okay, because that's the first thing that I did. Then for your connective and, you don't want to do anything there yet because you don't have anything to the right of it yet. So for Q, Q is just Q. So I'm just going to write down what Q is. True, false, true, false. So Q, I just got it from my column Q. And I'm going to call that number 2. Okay, so now we're going to figure out what our answer is. And that's going to be for the connective, we'll call it 3 here. So since we have our connective is and, we're looking at the conjunction here. So if you have this table available to use, then you would always have it with you. But for example, in my class, I don't give them that table, so they need to know when is the conjunction true and when is it false. So again, the conjunction is going to be true only if P and Q are true. So here I have false and true. They're not both true. So that means that this is going to be false. Okay, so now here I have a false and a false. They're not both true, so this is false. Then I have a true and a true, so that's the only time that this will be true is when they're both true. And then the last one is true and false. They're not both true, so this is false. So this column number 3 is what your answer would be, okay, for the statements. Let me go to the next slide. Let's see. And I don't see, or can somebody, oh, here, I'll click it on my other computer. All right, so now let's try this one. So now it looks a little bit longer, right? And that's okay. So we only have 2 statements, right? We have P and we have Q. So that means I'm gonna just use the one with 2 statements. So let me go ahead and draw it here. So we have P is right here for P, and then I have Q. And then I'm gonna write negation P or Q, and then or Q. All right, so we start by filling in the 2 columns on the left side. So again, as I mentioned, those columns on the left side are going to be the same. So true, true, false, and false. And then Q is true, false, true, false. And so just like any other math problem, right? If you have parentheses, you want to deal with the parentheses first. So first, I'm going to take care of negation P. So for negation P, if I have true, then this is going to be false, right? So I'm looking at P here. And then I have true again, so that's going to be false. And then false would be true, and false would be true. So I'm going to call that number 1. And then I'm still working with the parentheses, right? So Q, I'm just going to copy Q. And so that's number 2. And so now I can do the conjunction here. I'm going to call it 3. So we have false and true. They're not both true, so this is going to be false. And then we have false and false. And so they're not both true. Oh, wait, hold on. Let me go back, right? Because I did a mistake. What is my mistake? Both true. Oh, wait, hold on. Let me go back, right? Because I did a mistake. What is my mistake? Anybody see it? Let me erase this really quick. So it's important to check. Oops, wrong one. It's important to check what you're doing to make sure that we're following the rules here. So I was doing the conjunction, but it's not conjunction, right? It's going to be disjunction, right? Because my symbol is disjunction, which is right here. All right, so let's start again. So we have false or true. So as long as one is true, it makes it true. And then we have false or false. One has to be true, so this is going to be false. And then true, true, at least one is true, so that's true. And true, false, at least one is true, so that's true. So that's going to be my disjunction. So now we can go to the outside of the parentheses. We have a negation, okay? So what are we negating? We're negating this parentheses here. And so we're looking at number 3. We're going to negate it, and we're going to call it 4. So let me circle it in red. So to negate it, what we're negating is this last column that we worked on. So you always want to go back to the last column that you did. So the negation of T is going to be false. The negation of false would be true. The negation of true would be false. The negation of true would be false. Okay, so now we already did everything on the left side. Now we have disjunction Q. So for Q, we have, let's write it down, true, false, and then true, false. And we're going to call this our 5th thing that we did. So what are the last two things that we worked on? Well, we worked on 4 and we worked on 5. So that's going to create our final answer, which we can call 6. So 6 would be your final answer here. Okay, so we're going to look at false and true. So false, and our symbol is disjunction. So false or true, as long as one is true, it makes it true. Then we have true or false. As long as one is true, it's going to be true. And then false and true is going to be true. And then we have false and false, which is going to be false. So my answer is going to be this column number 6. Okay. Any questions on that one? Okay. Now if you, and we'll talk about this next week, but if you get all truths as your final answer, this is called a tautology. Okay, so a tautology just means that all your answers here are going to be true. All right, so let's go on to another one. Let me use the other computer to switch. All right, so now we get it's a little bit more busy here. So let's see. First, decide how many, which table you're going to use, right? You only have 2 symbols, two statements, P and Q. So we're going to have P and Q. So let me just draw that out. So P and Q, true, true, false, false, and true, false, true, false. All right, so then our symbol here is P or bracket, negation, P and negation Q, and then we have a bracket. Okay, so this is like that. All right, so you want to see where do you start first? We want to start inside of the brackets. Okay, if you wanted to fill in the first P, that's fine, but just we can start inside of the parentheses just to keep track of what we're doing. So here I have a P. I'm going to go ahead and, oops, hold on, give me a second. Okay, sorry. All right, so we have P, which is going to be true. And okay, so P is true. And then true, false, and false. And I'm going to call that number 1. Okay, so then the next step is do the negation of Q. So negation of Q, notice that Q is true here, so the negation would be false. And then you have false, so the negation would be true. And then true is going to become false, and false would become true. So that's going to be our number 2. Then you want to use 1 and 2 to do that middle column, which we'll call 3. That's going to be your conjunction, the and. So in order for it to be true, it's going to be true whenever both are true. So for the first one, we have true and false, so that's going to be false. Then we have true and true, that would be true. Then we have false and false, so that's going to be false. And false and true would be false. And then that takes care of the parentheses. Now we're going to stay within the bracket. So my next column would be this negation, 4. We're going to call it 4. So what exactly are we negating? We're negating the last thing we did, which is column 3. So for column 3, we're going to negate it. So we have a false, so that's going to be true. And then we have a true, so that's going to be false. We have a false, so that's going to be true. And then false would be true. Okay, so that's our last column with those brackets. And now I can do 5. I'm going to call it for P, true, true, false, and false. And then we can do our final answer. We'll call it 6. So in order to get 6, it's going to be the last two things that we did. 6. So in order to get 6, it's going to be the last two things that we did. And that's going to be column 4 and column 5 to give us 6. Our symbol is the disjunction. So remember, for disjunction, as long as one is true, then the whole thing is true. So we have true and true is going to be true. True and false would be true. False and true would be true. And false and true would be true. Okay, so everything is true. So this is actually a tautology, which later you'll see why we call it that, but that's a tautology. And I think I have one more. Yeah, so now we have one with a conditional. Okay, so let's do that one. So let me go ahead and draw it here. And then next week we can do one with 3 statements, so P, Q, and R. So we have P and Q. So true, true, false, false, and then true, false, true, oops. All right, so false, true, and false. All right, so here we have our bracket, P and Q or negation P, bracket, and then our arrow for if then, negation P. So I'm going to do P, well, let's stick with the parentheses. So Q is true, false, true, false. So that's my number 1. And then I have negation P. So that's going to be false, true, false, false, true, and true. So that's number 2. So we're taking our P, that was true, so we have false, true, we have false, false, we have true, false, we have true. So now for the inside, the middle one for the connective, we have the or symbol for the disjunction. So we have true, false. As long as one is true, it's true. False, false is going to be false. True, true is true, and false, true is true. Then we're going to do this for the P over here. So that's true, true, false, and false. And then we're in the bracket. So my last one here is 5. And in order to get 5, I use the last two things I did, which is 3 and 4 to give me 5. So my symbol is the conjunction and, so they both have to be true. So I have a true and a true is going to be true. True and false would be false. False and true would be false. And false and true would be false. Okay. So now we go to, what number are we? 6. Negation P would be false, false, true, and true. And then our final answer would be column for 7. And in order to do 7, I have to look at 5 and 6. So we're going to look at this. And then our connective is the if then symbol, so the conditional. And the conditional is going to be true everywhere except for whenever you have a true false. Okay. So what are we looking at here? We're looking at true with false. So when it's true false, we get a false. Then we have false and that's going to be true. Then we have false and true, that's still true. And then false and true is still true. So this is our final answer. Okay, so that was how to make a truth table with 2 statements. Next week, we can look at one with 3 statements, and then we'll look at some other stuff there. But that was it for today. So if you have any questions, you're welcome to stay, and we have some tutors here that can help you. Otherwise, we'll see you next week.
Thank you so much, Ms. Chuka, for your presentation. We do want to remind you all about the previously recorded sessions, which are available on the YouTube playlist. This session will also be available on that playlist later today. And before you all leave, I want to share the TVE sessions that we'll have next. So let me go ahead and pull it up so that way we can show you real quick. Okay, there we go. So at 1 p.m. today, we will have a presentation on, okay. There we go. So at 1 p.m. today, we will have a presentation on empowering student success, an overview of the Student Support Services Program at EPCC. And we will be back next week at 11 a.m., where Math 1332 will cover conditional and related statements, symbolic arguments, and Euler diagrams. And Math 2412 will cover verifying trigonometric identities and implementing trigonometric formulas. Our 1 p.m. session next week will be a presentation on DegreeWorks with Sonia Santana and Astrid Arciniega. Thank you all for coming in today. We hope you all have a lovely weekend. And if you have any questions, feel free to use the chat box or your mic. We hope to see everyone again for Happy Math Hour.